இதுல தான் கிளிக் பண்ண சொன்னாரு. அது போதா கீழே?
போதுல.
இதுல போய் டபுள் கிளிக் பண்ண சொன்னாரு. உங்களுக்கு பண்ணுங்க.
மேம் இப்போ வாய்ஸ் கேட்கல மேம்.
இதுல போய் டபுள் கிளிக் பண்ணுங்க. இது நெட்வொர்க்ல என்ன? வந்துச்சு. லேண்ட் கேக்குது. லேண்ட் இல்ல.
கேக்குதா உங்களுக்கு?
இப்ப கேக்குது மேம். இப்ப கேக்குது மேம். இப்ப
ஹெட்செட் ரிமூவ் பண்ணாதான் கேக்கு. சரி ஹெட்செட் எல்லாமே நான் எதுக்கு தேவையில்லாம இது பண்ணுவோம்.
பசங்க வராங்க.
Camera.
Screenshot எடுத்துங்க அப்படியே. Good morning, students. Hope you are all fine. Today we are going to have an introductory session about Cisco packet tracer. Now we have an introductory class about that. Dr. Savita from NWC will take over the session. Now I request our audit professor ma'am, HOD NWC, Dr. Annapurni Panayappan, professor, to give an introduction to the students about the course. Ma'am.
Good morning. Can you hear me? Can you hear me, sir? Am I audible?
You are audible, ma'am. You are audible, ma'am.
Okay. Am I audible now? Hello?
Yes, ma'am, audible, ma'am.
Oh, okay. Good morning to one and all present here. It's pleasure meeting you all, but we are meeting in online today due to the main thing is I would like to see you all in person also. We will have the next meet, okay, after a few days. Once you have all written back. Tomorrow you have your exam, you could understand that. But this will be only for your demo purpose because you have your lab session. Today it's a practical one. And you will be doing with Cisco packet tracer. So Sapta ma'am is doing with CCNA courses. So she is an expert in computer networks and computing networking applications and other things. So she will be informing you how to go with the thing install and then. First of all, I would like to inform you that this is a very basic subject that's a core in your computer science and engineering, which is more important like the other subjects. So whenever you feel that subject is good for you and really you have to get into it, and if you create an interest for you could learn the subject. So that's the foremost thing over here. So just you could see, and we have now informed your subject teachers to give you the course plan, how the assessment will be carried out, what is the course outcome, how it will be help you to attain your program outcome, and then this course, how it will be, that is how the assessments will be done, and what will be the that is the syllabus, how it will be taken. All these will be discussed by your faculty subject teachers, whoever is handling you. And if you have got any queries, any doubt related to this subject, you're welcome. You can ask us. You have got the concerned course coordinators in addition to your subject teachers, you can get into it. But if you are not able to follow or you have got any doubt, you can talk to the concerned course coordinator. If not, you can even approach me so that we will help you out. Because this is the thing which you will be able to learn only when you practice and get into it. This will be really interesting for you. So for that only today Saksham is here to just discuss about you what is this computer communication, what all the components you have, and how in Cisco packet tracer you will be able to do these activities. So not taking much of your time, I will hand over the session to Savita ma'am, and because by 9:40 you can even send a reminder. I think your course gets over by that time. That's a practical duration which gets over by 9:40. And since all the students have joined by both batch 1 and batch 2, hope all the students have joined here. You need not join the batch 2 need not do the afternoon session. So morning session itself, since all have joined, you people can do the morning session. You need not join the afternoon session. So I hope all the students have joined and your attendance will be here. Your faculty advisor will be giving you the form and you can fill and then give your attendance to your subject. And I will now hand over the thing to Savita ma'am. She will be taking the decision. Savita? Hello? Okay, till she comes, generally the thing is what you know about your computer communication is just you have seen that when we are sending something through your mail, Savita ma'am has come. Savita, you can carry on, drama.
Yes, ma'am. Yes,
Okay.
ma'am. Yes, ma'am. Thank you, ma'am, for the introduction. Hello, students. So let us get
Now
into
also
the
join in YouTube.
topic.
Pardon, ma?
No, ma'am. Nothing, ma'am. Good
Okay, you
morning,
can go
students.
ahead. Start.
Thank you, ma'am. Good morning, students. So today we'll see the introduction to Packet Tracer. So I am Savita. I'll be handling this session, and why we need to um understand this session is basically Cisco Packet Tracer. It is basically a simulation tool which is used to simulate and practice the networking concepts that you study in the real time. Okay, so what we are going to see here today is we are basically going to see the platform, the interface, what are the various options are there, what is the menu, and how we are going to work with the various tools and how we are going to simulate the software. One second. Ma'am,
நீங்கள் ஸ்க்ரீனை ரிலீஸ் பண்ணுங்க உங்களுக்கு கெஸ்ட்டு நல்லா இருக்குங்க. ஃபோன் சொல்லு
சொல்லட்டுங்க.
சார் நான் யூடியூப்ல அந்த லிங்க் போய் கரெக்டாக ப்ளே ஆகிட்டு
Sorry, students. So I will just share my screen. I am stopping my camera so that I'll be able to explain to you better. Okay.
அப்படியா? ஓகே, கொஞ்சம் டிலே ஆகுது. ஓகே 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 ஓகேங்க. ஆ கொஞ்சம் டிலே ஆகுது.
So this is a Cisco Packet Tracer. So how you can install this Packet Tracer, I will let you know. So we know Cisco is the leading software company which is used. So how you can install this Packet Tracer, I will let you know. So we know Cisco is the leading software company. So this is a leading software company which produces hardware devices, and basically you can use all these devices in a real time. So if you want to purchase these devices, these are costly devices. So that is the main reason we are using this simulation software where we can do all the configurations and we can test it. So this is a useful tool for doing practice and to analyze the network and also to do the troubleshooting. So this is the best tool for a beginner to understand about networking and to practice the various commands, how to troubleshoot. So most of the administrators, they rely on this Packet Tracer tool basically to see what is happening in the network, because we know the in network is a huge, and there are a lot of challenges. And basically by looking at these tools, like we have another tool called Wireshark. So that is also basically used to capture the packets that are transferring in the network. So by analyzing these tools, we can understand or we can find out where is the problem, and we can troubleshoot it. So that is the main reason. Okay. So first, this is the Cisco Packet Tracer. So how to get this software? So first, you can log on to netacad.com. So Cisco is providing you a platform which is called as NetAcad, where the user, which means the students, you can log in. It is a free website where you can log in, register, and you can download the Cisco Packet Tracer. Also, there are a lot of courses that Cisco is offering free of cost for the students, where you can download and you can study those courses. And also, we at SRM also provide CCNA training, and we have more than 6 trainers who are trained in Cisco from the Cisco Academy. So we are the instructor trainers who will be helping you in learning this subject. So first, let me explore the various tools and the menus in the Cisco Packet Tracer. So this is how your Cisco Packet Tracer will be after installation. So the installation is very easy. You can just download the Packet Tracer. You can take the latest version, and once if you it's just a exe file. If you just click it, it will be automatically installed. So it just takes hardly 5 minutes for you to install the software. So once you install and open the Cisco Packet Tracer, you will be able to see this window. One second.
இந்த பசங்களையும் அந்த வெப்சைட்ல வந்து டவுன்லோட் பண்ணிட்டு உங்க கூட அப்படி ட்ரையல் பார்க்க சொல்றாங்க. அது ஒரு 4
So
minutes time.
if the students are having if the students are having laptop, you can download this software. I will just wait for 5 minutes so that you can install it and you can work it along with me. So students, if you are having a laptop, you can just directly you can also type Cisco Packet Tracer and just install it in your system. See students, if you are able to download the Cisco Packet Tracer, you can download. Otherwise, in 2 minutes time, we'll be giving you the link in the chat box so that you can install from there. Okay. So other students, meanwhile, you can download Cisco Packet Tracer in your system.
Cisco version report
See, students, we are just sharing you the link so that you can download from the drive link. So others, those who are installed, no issues. Okay, students. So now we'll see how what are the various options in this Cisco packet tracer. So we are having the menu bar at the top. So if you open the Cisco packet tracer, you have the menu bar at the top which has the options like file, edit, options, view, tools, extensions, and help. Then we are having the menu bar where we are having various tools. I will tell you what are the various tools, and this is called as your workspace where you can do the various configurations and you can test it. And at the right side, we are having the common toolbars, and then at the bottom we are having the various devices that can be selected, and in the next window we are having the various to select a specific device, like I will tell you the options as I proceed. And then here you can see the packet that you have simulated and whether the communication was successful or not, so we can see that. So let me first get into the first um, topic. So if you click on the one second. Students, once again, I'll just present my screen again. Actually, my screen is not getting shared. Okay, so this is a window. So first, in order to make an initial communication, actually the screen is getting loaded slowly. So first, for to establish a communication using the Cisco packet tracer, what we need to do? So first, we need to have a device. So a device is like basically you can see the various options over here. So where we can see the network. So you have to move your mouse and you can find the various devices that are available in your Cisco packet tracer. So if you go to the file menu, you have options to open a file, save a file, and in the edit options we have the various options like copy, paste, undo, and in options we have preferences, user profile, algorithm, view button, then the various tools, extensions, and help. So I will be teaching you the basics. Later you can explore the tool later. So first, in order to establish a simple communication in a packet tracer, you need to add the end device. So end device is nothing but a PC. So here I'm just telling you the various devices that are available. So in the networking devices, first you have the end devices. So if you click on the end device button, Here you can see the various devices like PC, laptop, server, um, IP phone, VoIP phone, TV, wireless devices. So you can connect the various devices that are required. Then we are having the components like MCU board, SB board, and then in the next button, if you click, you can see the various types of cable that you can use for a communication. So if you look at the cable, you have an automatically choose cable. Then we are having the console cable. So as I'm doing the scenario, I will tell you what is the use of the various cables and what cable you have to use to connect two devices. So the console cable will be basically used to connect to from a PC to a router. Then we are having a copper straight through cable. Then we are having a copper crossover cable. Then the fiber optic. Then you have the phone cable. Then we have a coaxial cable. Then serial cable, and then we have the octal, then IoT custom cable, and we are having the USB. So if you click on the next icon where you're having uh, miscellaneous, so if you want to choose any specific router or the PC, you can choose that. Okay, so then we are having the option for a multi-user. Okay, so first let us see how to establish a simple connection in a Cisco packet tracer. So the first device that we need to connect in a Cisco packet tracer is you need to have a PC. So for a communication to happen, we need two end devices, and for a successful communication, we need to transfer the data from one system to the other system. So we know you can go for wireless or wired medium. So here I'm going to show you with the wired medium. So in order to transfer our data, so I'm having two PCs called PC1, PC0 and PC1. So for I will just name it, let me give a label called 10.0.0.1. I think you will not be familiar with the IP addressing and subnetting. Bear with me, like later you will understand, but for time being, you need to understand that if there are two PCs and if they need to communicate in a network, you need to have something like you have a name or an address. So likewise, the devices in the networks will be having something called as IP address. You also have something called as a MAC address. So MAC address, I will tell you what is the importance of MAC later. Okay, so I am giving two IP addresses. So this is for you to understand. I'm just clicking the label. So I'm having two PCs called 10.0.0.1 and another PC called as 10.0.0.2. So first, in a real time, if you're having a system and you want to make your system communicate to the internet, so for that you need to install the TCP/IP software, or you need to install the networking software. So once your networking software is installed successfully, only your system will be able to communicate to the net. So after installing, how will you test whether your system is ready to connect to the net? So you'll be basically pinging the IP address call as 127.0.0.0.1. So I will show you what exactly you need to do. So first, for these two PCs to communicate, so you need to understand what type of cable you need to use for communication between the two devices. So you can either go for a straight through cable or a crossover cable if you want to connect two devices. So you need to understand the difference between a straight through cable. So you have various cables over here, and if you point to the mouse here, you can see there is a cable called as straight through cable and the other cable which is called as your crossover cable. So whenever you are connecting two like devices, so two like devices means a two similar type of devices, we have to use like devices means crossover cable, unlike devices means straight through cable. Okay, otherwise you can also go for a automatic cable. So first let me, I'm just showing you by connecting a straight through cable. So if you click on the PC, you'll be able to see the various ports. So you're having a RS-232, which is nothing but a serial port, and then we are having the USB port, and then there is a port called as fast Ethernet. So you just need to click on the PC and you need to click on the other PC where you have to just click on the fast Ethernet. Okay, so here you can see initially it is having a red color. So once the connections are correct, you'll be able to see a green color once you uh, give the correct configuration. So I need to go and enter the address. So as I told you, I am going to configure this address called 10.0.0.1 to this particular PC. So I am connected to a port number. So here I have enabled by default the preferences. So if you go to options and preferences, here you have something called as always show the port labels. So always show the port labels will help you to understand what port you are actually using. So I'm using a port number called FA0, and here also I'm connected to the port number FA0. So you have to go and log in and give the correct. So if you look at the physical, so here you can see the actual um, how the actual image will look like. So here we are having this card. So this is called as your network interface card, where which will be useful to connect you to the internet. Okay, so you have to go to config, go into the fast ethernet, and then you have to go and give the IP address. So IP addresses are basically, as I told you, it is like to identify a particular device in a network layer, we give a IP address, and IP address is a 32-bit address. It is represented as a dotted decimal notation. So you'll be representing as an 8 8.8.8.8. So you can represent it as, for example, here I'm giving an example called 10.0.0.1, and there is a subnet mask. So you'll be studying IP addressing, subnetting all later, because I'm not getting into the details. So you just need to understand I'm assigning an IP address. By default, your system will automatically, based on the range of IP address you are selecting, it will be giving you the subnet mask. And the role of subnet mask will be basically used to identify what is the network address that is used to connect to the network. So I have assigned an address called 10.0.0.1, and for the other system, I'm just giving an IP address called 10.0.0.2. And if you click on the subnet mask, by default, it will be populated. So I have just put two PCs. I have just established a connection. I have just put a cable between the two devices. And after that, you need to send some data from one device to the other device. So for that purpose, in the Cisco packet tracer, here you are having a mailbox type of button. So here you have the option of adding simple PDU, or you can also generate complex PDU. So I need to send some data from one system to the other system. So for that purpose, you have to just click on this SMS button, and you have to drop it. So you have to use your mouse to drop the packet from one system to the other system. Okay, so once you drop the packet, here you can see that there is a the packet is failed. Okay, so this is a workspace where you are able to generate, and here we are having it in a live real-time network. So you can also turn into simulation mode and you can use it. So now you need to understand what is the reason why you are not able to ping. So let us go into the next button. So here we are having, if you click on this PC, here you can see various icons. So we have various icons like IP configuration, dial-up, terminal, command prompt, web browser. You're having the PC wireless, VPN, traffic generator, MRB browser, Cisco IP communication. So these are the various tools that are available. So currently I'm going to just get into the command prompt. So if you get into the command prompt, so for this PC, how to check the IP address of the PC? So for that, you have to give the command called ipconfig. So if you give the command called ipconfig, you'll be able to see. Okay, so there is a delay. I will just go slow. So 1 second. I think there is a delay. I am able to work a bit faster.
கன்வி பண்ணிக்கோங்க. சிஸ்கோ ஓப்பன் பண்ணுங்க.
I think now you are able to see my screen. Okay, so if you get into the PC, you'll be able to see, if you type the command called ipconfig, you'll be able to see the IP address, the MAC address, and by default, your system will be also having the IPv6 address. So IPv4 is a 32-bit address, whereas IPv6 is a 128-bit address. So nowadays we are using IPv6 address. So every PC will be having two types of addresses. One is called as your IP address and the other one is called as your MAC address. So a MAC address is a 48-bit address. It will be basically represented as a hexadecimal value. So 24-bit will be represented for your OUI and 24-bit will be represented for the device. So I have given an IP address called 10.0.0.1. So likewise, if you get into the other PC, so again, you have to go into the command prompt and you have to just type the command called ipconfig. So if you're typing the command called ipconfig, here you can see that I have assigned the address called 10.0.0.2 to this particular PC. So if you want to communicate or you want to send some packet, so here I have dropped this packet from this PC to the other PC. So likewise, you can also go and ping directly from this PC. So I am currently in the PC1. So here you can see my IP address is 10.0.0.1. I need to ping to the other PC. So in order to ping to the other PC, you can just type the command called ping. So ping stands, the ping abbreviation is packet internet gropper. So you have to type the command called ping and just type 10.0.0.2. So if you type 10.0.0.2, you will be able to get a reply. So basically from my PC, from this PC1, it is sending some packets and you will be getting a reply. So basically you will be, the system will be sending 4 packets and you will be getting a reply. Okay, so here you can see there is a request timed out. So we need to understand what is the problem, why the system is not getting pinged successfully. So here, if you look into the statistics, here you can see there are 4 requests timed out and there are 4 packets that are sent and received packets is 0, which means that my system was able to send some data, but I was not able to receive any data. And there is a loss of 100%. So this is a basic way you need to troubleshoot a communication or the devices in a Cisco packet tracer. So we'll see what we can do. So the first thing I told you, when we are connecting two like devices, we have to use a crossover cable. So what cable I have used? I have used a straight through cable. So which means here you can see a straight through cable is a single black cable. So we'll just try removing the cable. So how to remove this I want to remove this particular cable. So there is a button called this delete button. You have to just cut the link. Okay, so I have successfully deleted the link between the two devices, and then if you press the escape, you'll be able to come out. So next, let me try the same thing with the crossover cable. So if you're having like devices, we have to use a crossover cable. So you have to again click on the PC, go to fast Ethernet, and again you have to click on the PC and go to fast Ethernet. So now you can see, so initially previously we were able to see the red color icon or red, you can see the red color. Now you are able to see that the color has been changed to green. So which means it is perfect. Okay, so now let us see whether the communication is successful or not. So my PC address, the first I am in PC1, my address is 10.0.0.1. So let me give ipconfig. So I'm in, my address is 10.0.0.1. So I need to communicate to the other system. So I'm going to give ping 10.0.0.2. So now you can see I have sent some data from PC1 and I am receiving a ping reply. So you're getting a reply from the other PC. So reply from 10.0.0.2, and I sent a 32 byte of data. So in the ping, you have various options. You can play around with it later. So I'm getting a reply for 32 byte, then the time, and also the TTL value. It's 128. So here, if you look at the statistics, you can see the send packet is 4, received packet is also 4, and the lost percent is 0. So which means our communication was successful. So likewise, for the other side also, you can ping. So you can get into the other system and just you can try ping 10.0.10.0.0.1. So you can see that the other side also you were able to communicate successfully. So you can directly get into the command prompt and test, or the other way in the packet tracer itself you can test by just dropping this packet from one system to the other system. Here you can see there is a successful. So you can test it from the other side also. From PC2 to PC1, you are able to see the successful message. So here currently we are in the real time mode. So I can just delete the packets over here, and let me show you the same thing in a simulation mode. So simulation mode, you can see the packet flow from one PC to the other PC. There is a capture forward. So here you are having a capture forward button where you can play it and then you can see. Okay, so I will just show you the same configuration in the simulation mode. Okay, so I have dropped a packet from PC1 to PC2. So which means I'm pinging 10.0.0.2. So here you can see there is an in progress. So first you need to click on this capture forward. So here if you just click, you can see there is a first packet that is being sent from PC1 to PC2, and then there is a second packet that is sent from PC2 to PC1. So here you can see there is a successful message. Okay, so I have just deleted the packet. So we have given the IP address. I told you something about the MAC address. For any communication to happen in a network, the systems need to know the MAC address of the other system, and only then the data will be delivered from PC A to PC B. So what is a MAC address? I told you MAC address is a 48-bit address. So let me see whether my PC has learnt the MAC address of the other system. So for that, you have to type the command called ARP-A. So I will tell you what is the use of ARP protocol. So ARP is a protocol that is basically used to learn the MAC address of the other PC. So whenever I am sending a packet from one PC to the other PC, so for example, my address is 10.0.0.1, I am going to send a packet to 10.0.0.2. Unless I know the MAC address of the other PC, I will not be able to transfer my data. So my PC will be using a ARP protocol. So ARP stands for Address Resolution Protocol. So what it will do, Address Resolution Protocol, I know I want to communicate to 10.0.0.2, but I don't know the MAC address. So this ARP protocol, what it will do, it will go and fetch the MAC address of the other system. And once I get the MAC address of the other system only, my data will go to the other system. So this is how the PCs will be learning the MAC address. So if you go into the other device also, you will be able to see that this PC has also learned the MAC address. So here you can see it has learned the MAC address of 10.0.0.1. So without learning the MAC addresses, two systems cannot communicate. So that you need to understand very clearly. So let me show you the same demo by deleting this ARC table, and now we'll see how in this simulation mode how we are able to transfer the data. Okay. So in order to remove the ARP entry, so you have to give the command called ARP minus D. So once if you give ARP minus D, you will be, now again if I'm giving ARP minus A, you can see that there is no ARP entries found. So your PC will, in your real time, not only packet tracer, in your real PC also, you will be having something called as your ARP table, and whatever addresses it is being learned, it will be populated in the ARP table. So I have deleted in PC1. So let me go and delete it in the PC2 also. Okay, so I have deleted the ARP entry. So now let me show you again ARP minus A. So now you can see there is no ARP entry. So let me get into simulation mode, and again, let me again show you the same thing, how the system is able to get the ARP address or the MAC address, how the ARP table is populated. I will again show you. Okay, so first again, I want to ping from PC. So if you just click on this PC itself, here you can see it is showing you in what port it is being connected. So I'm going to ping from PC 0 to PC 1, or which means like 10.0.0.1 to 10.0.0.2. So here I'm going to click on the capture forward button. So in this packet itself, you can just click and you can see that there is an R packet being the packet being sent. So here you can see the sender IP address is 10.0.0.1 and the receiver IP address is 10.0.0.2. Okay, so I'm just going and giving the click forward. So first you can see I have received a packet. So there is a ICMP packet and there is a R packet. So here you can see it has learned the MAC addresses of the PC, and then after that you can see there is the ICMP packet that is exchanging between the two systems, and then you can see the successful message. So here you can see there is a source IP address, destination IP address, and it has learned the MAC address of the other system. So let me get into the MAC table. So previously we deleted the table, right? So now again we can see whether it has learned ARP minus A. If you type, it has learned the MAC address of the other system. So likewise in this PC also, if you go and see, it has learned the MAC address. Okay, so this is how your system will be learning the MAC address, and then it will be able to communicate. So in the simulation mode, you can see the various sequence of packets. So in ICMP, here you can see who's I from 10.0.0.1, I'm communicating to 10.0.0.2. Then in the R packet, so here you can see. So the R packet I told you, right? ARP stands for Address Resolution Protocol. From the source IP address 10.0.0.1, it will be forwarding to the destination IP 10.0.0.2. Okay, and the MAC address. So it will know its MAC address, but it will not know the other MAC address. So that is the main reason you can see there is a broadcast packet being sent. So broadcast packet means it will be forwarded to all the devices that is connected to the network. So since I'm communicating to 10.0.0.2, 10.0.0.2 will know its MAC address. So in the next packet, it will be replying it with its MAC address. So here you can see it will be replying with the MAC address. So 10.0.0.2 will be providing its MAC address. It will say, I am 10.0.0.2 and this is my MAC address, you take it. So that is how the ARP protocol will work. It will give its MAC address, and then you can see there is an ICMP packet ICMP packet exchange happening between the two nodes. So this is how you can establish a successful communication between the two devices. So again, I'm going into the real time mode. I think hope this is clear for you. Okay, so next we'll go into the next scenario. So the next scenario is I have connected two PCs, but I wanted to connect two more PCs. So what I can do is I can just add two more PCs, and where will I connect it? So we know so if you click on the PC, so for my understanding purpose, I have just um, given this address 10.0.0.1. So for adding more devices, you need to have another type of device. So that is called as your hub. So since you have not had the theory class, I will just explain you the basics and I will just show you how you can connect. So I'm just going to cut this connection. So if I want to add more than one device, I need to use a device called as hub. So if you click on the network devices, end devices, so you have to just move this icon. So where you can see, so here we are having routers. So in the routers, we are having various series of routers. Then we are having switches, and then we are having hubs. So the next device that we are going to see is called as your hub. So hub is a layer 1 device. So one second. Okay, so I want to connect more than for example, let me say I need to connect some 3 or 4 PCs. For that connection purpose, I'm using hub. Okay, so hub. So I think you will not know about OSA layer. So I will just tell OSA layer is a default basic layer for understanding networking. So OSI basically has 7 layers. So first you have physical layer, then data link layer, network layer, transport layer, then we're having session layer, presentation layer, and the application layer. The bottom layer is called as the physical layer, where you are connecting all the physical cables. The physical layer will be basically dealing with these cables, the type of topology. Topology is like how do you arrange the devices in a real time, and you will be also talking about the various specifications, like what is the electrical specifications, like how much power it should use, what is the type of encoding that it needs to follow. So all these will be dealt with your physical layer. So now I have just connected a hub, and I'm going to uh, establish a connection between these devices. So first I'm going to use a copper straight through cable. So as I already told you, you just need to click from the PC to this hub. So here you can see there is a green button, which means the connection is successful. Again, you need to click the next button called copper straight through. You have to click it on your PC, and then you have to connect it to the hub. So likewise, you have to go and connect all the cables to the hub. So next I'm connecting the next device to the hub. Okay. I'm again connecting another device called PC4 to the fast ethernet. Now you can see these are movable, so you can just keep it and you can just move it. Okay, so for the time being I will just disable the options over here. In the preferences you have the option called show label. I'm just disabling it. So here now you can see that I have connected 6 PCs, and I want to establish a communication between these 6 PCs. So if you click on the hub, you can see the various the ports. These are the various ports. Hub is nothing but it is again a simple network device that is used to connect various devices in the network. So here you can see this hub is having 6 ports, and you can connect 6 different PCs to this hub, and there is a green button over here, which means you can just power it off and you can turn it on. Okay, so power off, power on. So I have just connected 6 PCs, and getting to the configuration, there is no configuration. And the basic thing that you need to understand about the hub is a hub is a layer 1 device. Here you can see what is the link status. So all the links are up. It is not an intelligent device. It will not learn which PC is connected to which port. Okay, so it is a non-intelligent device. And how it will work. So hub is a broadcast device. So you understand a broadcast means if a single person, so for example, if this PC1 is trying to send some data to the hub, this hub will be broadcasting it, or it will be sending the data to all the remaining 5 PCs. Not only the first time, always the default setup of the hub is it is always a broadcast device. So let me go and quickly give the IP addresses so that we can work with the hub. I'm giving the address called 10.0.0.2 to the next device. Then I'm assigning 10.0.0.3 to the next device. I'm assigning 10.0.0.4 to the next device. Okay, for this PC, I'm giving 10.0.5. So this is a note, so you can fix. Okay, so I'm using these addresses, so I have just shown you. So now we have to go and configure the various IP addresses in the PC. So how you need to configure? So you have to go to configuration, and then you have to give 10.0.0.1 subnet mask. By default, you give it as 255.0.0.0. You will understand IP addressing subnetting later, but for time being, you just follow with me. Okay. By default, it will give you the address. So next, so the next is 10.0.0.2. By default, okay, I have already assigned it to this PC, right? So let me go and remove it. Start system. Okay, I have assigned this address. So we'll see that too. It is showing it is already being used in the network. So I'm using an address called 10.0.0.4. This is 10.0.0.6. So here you can see initially I have assigned 10.0.0.2 to the system. So it was not allowing me to use the same address. So this is 10.0.6. Now I'll be able to assign this address called 10.0.0.1. This is 0.2. Okay. So now you can see that I have assigned various addresses. I have assigned 1, 2, 3, 4, 5, 6. So these are the various addresses that I am using. Now we'll see how the hub works and whether we are able to successfully communicate from one system to the other system. So either you can go into the command prompt and then you can type in, or you can just drop the packet from one PC to the other PC. So I'm in PC1 right now. So here you can see I'm in PC1. I'm going to ping 10.0.0.6. Okay, so I can see that I am able to successfully receive a packet from the other PC. Okay, so otherwise you can drag and drop this packet from PC3 to PC4. Here you can see there is a successful message. So likewise you can ping from different PCs and you can just check. So if the communication is successful, here you will get a successful message. So now first we'll try to understand how exactly your ping works. So I told you in the first point itself, always the hub will be doing a broadcast. So if you are in the real time mode, you will not be able to see what is the broadcast, how it is happening. So you can just click on to the simulation mode. So simulation mode, I'm just deleting the packets over here. Again, freshly I will show you how it is learning. So let me go and show you whether it has learned any art. So it has learned. I pinged from PC1 to PC6. So it has already learned the MAC address of PC6. So let me go and delete it. So how to delete? I'm just going to give the command call ARP minus D. So I have deleted the entry. So similarly, I have so it has learned two addresses. So I'm just going and clearing the ARP. So I've just cleared the ARP entry in the system. Okay, so now let us again ping from PC1 to PC6 and we'll see whether hub is doing a broadcast of the packets or not. So I want to communicate from PC1 to PC6 and I'm just going to click the capture button. So as I told you in the first itself, whenever any communication happen between two systems, there will be an R packet that is being generated So ARP is called as your address resolution protocol. It needs to know the MAC address of the other system for a PC to successfully communicate or transfer the data. So I'm just clicking this play button. So here you can see that there is an R packet being sent from, so here you can see that there is an R packet being sent from one PC to the other PC. So here you can see all the PCs are rejecting because it is not intended for them. So for this PC alone, you can see there is a tick mark, and here you can see the hub will be broadcasting it to everyone. So all the other places it is a cross, only this PC is a valid. So here it will be able to receive that data. So once ARP has been communicated successfully, then you have the ICMP packet. So you can see that all the remaining PCs, the packet will be dropped. Only the intended, you'll be able to see a tick button. Okay, so hub, here you can see every time it is receiving a packet, it will be forwarding it to all the remaining nodes. So there is a successful communication happening after the packet is being sent from PC6 to PC1. So here you can see there is a tick button, and the other places you can see there is a cross, which means these are not the intended devices. Okay. So here you can see that there is a successful message. So play, once again I'll show you. Let me ping from PC from a system called 10.0.0.3 to 10.0.0.4. So quickly I will go and clear the ARP entry. It is showing ARP, no ARP entries. So likewise, ARP minus A. Here you can see that there is no ARP entries. Okay, let me turn into real-time and simulation mode. Now again we'll see. Otherwise, I will show you in this. So if you click on the spacing, here you can see you have there is a pop-up, like it will show whether all these ports are up, what is the IP address, etc. So here you can see there is a fast Ethernet. Okay, so let me, it's not coming. So I'm going to ping from PC3 to PC6. Okay, so that is I'm generating an ICMP packet. For that, it is creating a ARP packet. So first there is a packet being sent to the hub. What the hub will do, it will be forwarding it to the remaining 5 PCs. Okay, I am talking only to PC4. So in PC4 alone, it will be replying. Okay, what the hub will do, again it will be doing a broadcast. So here you can see the packet will be forwarded to all the remaining PCs. So only the intended it will be accepting, others all you can see a cross mark. So once the ARP communication is successful, once it has learned the MAC address, it will be forwarding the original data packet. So now there is the ICMP message happening. You can see there is an, if you click on this, you can see. Okay, so here this is a successful message. Here you can see the tick mark, the remaining pieces there is a cross mark, and then you can see that there is a successful communication between the two nodes. So this is how you can understand what is happening in the network in real time. So now we have seen the working of the hub. So if you click on the hub is not having anything. It is not having any memory. It will not store which PC is connected to which MAC, etc. Okay, so a hub is a non-intelligent device. It doesn't store anything. Whatever data it is coming. So for example, if this PC3 is sending some data, it will be forwarding it to all the remaining PCs. So this is one of your drawbacks. If it is a few devices means this is okay. But imagine that you are having hundreds and thousands of devices, and every time the hub is simply broadcasting means it is unnecessary wastage of your bandwidth. Okay, so that is the main reason when you're having more devices, we will not preferably go for a hub. So in that case, we'll be going for another device called as switch. A switch is an intelligent device only for the first time. Only for the first time, it will do a broadcast. And once it does the broadcast, it will learn. Like all of them will be replying, right? So it will learn. piece 10.0.0.1 is connected to port numbers. For example, this 6 ports means I number it 1, 2, 3, 4, 5, 6 means it will say, it will identify 1 is connected to port number 1, 2 is connected to port number 2. Likewise, the switch will learn the port numbers and the MAC addresses of the various devices that are connected. Okay, so that is how your switch is intelligent and how it will work. So I will show you the next scenario by using the switch. Okay, so let me delete this device. Okay, I have deleted the hub. Next, let me go to the next network device. So here you can see a router will be visible. It is a round button. Then we are having a switch. So switch will be having, it is a box type of setup. So I can use any type of switch that I want. So for time being, I'm picking up 2960 switch. So you can connect switch anywhere. So you can move the switch. Now you need to connect. So just by having the PCs and the switch, you need to connect it, right? So for that, you need to go to the cable. So this is the cable. So PC and a switch is here. If you click on the switch, you can see switch is having more number of ports. So I'm just maximizing the switch. So this is how your switch will be looking like. So here you are having, I think it is a 24 port switch, and you can connect 24 different PCs over here. So here you are having fast Ethernet. One second. So you're having fast Ethernet 0/1 likewise. Let me get it into here. So here the device is still booting. So it is asking us to wait. So let us wait for some time. So if you, okay, the switch is booting. So let us wait. So meanwhile, we'll give the connections. So what cable I have to use? So these are not like devices, so I can go and use straight through cable. So okay, so from this PC I can go and connect it to the port number 1. So next PC you have to go and connect. So let me connect to port number 2. Next device I need to connect to the, so I'm connecting the next device to port number 4. Next I'm connecting to the next device. Next, I'm connecting the next PC. So I have to click on fast Ethernet and I need to connect it to this switch. I'm connecting to port number 6. So here you can see the switch it will, it will take some time for it to be up. So here you can see there are the 3 green color buttons, and here you can see there is orange. So orange is it's an amber color. So it's still, it is booting up. So it has not booted. So till then you have to wait. So meanwhile, we'll just have a quick recap of what I have told about switch. So switch, I told you, it is again, a switch is also uh, networking device. It is a hardware device that is used to connect more number of devices, and your switch will be basically operating in the OSL layer 2. So 2 stands for your data link layer, and a switch is an intelligent device. Okay, so now you can see that all the buttons are green, so which means the switch is ready, and now we can go and do the initial communication. So you can go and configure the switch, you can go and give the name, you can change the name, you can set up password. So all that you can do, but you can, that you will learn it in the lab. Okay, later you will be able to go to that. So I'm not getting into the commands, CLI commands. I'm just showing you the basic communication or the basic working or the difference between a hub and a switch. So hub and a switch can be used interchangeably, but the only problem is, as I already told you, switch will be learning the MAC addresses. Okay, it will be populating in a table called as your CAN table. So let me just show you. So MAC address table. So here you can see that the switch is currently having no MAC addresses. But after I communicate, if after I ping from one PC to the other PC, here you can see that there will be an entries being populated in the MAC table. So there is a successful message. So let me go into the switch. So in a switch, you can just use the up arrow So here you can see it has learned the MAC addresses. So it has learned from, this is the port number. So this is how your switch will learn. So this is called as your MAC address table or the CAN table in a switch. So VLANs and all, it is, you will study it later. But for time being, you just understand a device that is connected on port number 1, it is having this MAC address. Okay, a device that is connected on port number 4, it is having this MAC address. So this is how your switch will learn the MAC addresses. Okay, so let me enable the show labels. Now you can see it has learned this MAC address like FA0 bar 1, and it has also learned this 0 and 4. That is what we have seen here, right? So here you can see that it has learned the MAC address of this 1 and this MAC address of this system called 4. So we know that if you are transmitting a data from one PC to the other PC, you get a successful message that we are able to understand. You can either use this button, you can either use the packet tracer DPDU, or you can also call it as a PDU, which is called as a protocol data unit, to transfer the data from one system to the other system. Or you can also, as I already told you, you can go into the command prompt and you can just go and ping. So ping, what was the IP address of the other system? 10.0.0.6, 10.0.0.6. So if you click that, you will be able to get a reply. So since it has already learned, it is forwarding the data. So if I want to ping any other device, so let me put 10.0.0.5 also. Ping, 1 second. So here you are able to see that it is, you can ping from here also, and now you can go into the MAC address table and you can just check whether the switch has learned. It has learned that a particular MAC address is being connected to a port number called 5. Okay, so here, where is port number 5? So I ping from this PC, right? So here you can see it has learned, this is 6. 1 second, let me just sort it out. This is 4, this is 5. Okay, so it has learned this MAC address is connected to this port number. So let me get into the simulation mode and I will show you what is the difference between a hub and a switch. So let me delete all the other entries. Okay, I wanted a device that has not learned any entries. So let me R minus A, it's not having any entry. So I'm going to make a ping request from 10.0.0.3 to 10.0.0.4. Okay, I'm just clearing all the ARP entries and we will see how the switch is working now. Okay, so I'm just deleting all the entries so that you can understand how the switch is learning the addresses. Yeah. I'm just deleting all the entries so that you can understand how the switch is learning. Okay, this I have already done. Art Wednesday. So I'm just going and deleting the various entries in the system. Okay. So now I have cleared all the entries. So now let us go into the simulation mode and let us understand how the switch is working. So I want to ping from 10.0.0.3 to 10.0.0.4. So how it should work? So first time when this PC is trying to send a data to 10.0.0.4, as usual, there will be a ARP happening. Okay, so this PC will say, I'm using 10.0.0.3. I want to talk to 10.0.0.4. 10.0.0.4, give your MAC address. So there will be an ARP request being sent, and then this PC, it knows that the request was for this system and it will be giving its MAC address. And once the PC has learned the MAC address, and then after that only your ping packet will come. Okay, so this, you know what the PC will do. Now what this switch will do, so when the packet is being sent from the first device, it will reach the switch. First time the switch will not know which PC is connected to which port number. So the first time alone the switch will be doing a broadcast. So it will, for example, if I'm sending a packet from 10.0.0.3, it will be forwarding it to all the remaining ports. So it will be sending the data to all the PCs, and all of them will be replying. So it will be populating the, it will understand what are the various devices that are connected, and once it gets the reply, the next time onwards you can see that there will be a unicast. Unicast means there will be a one-to-one message that is being sent from this PC to the other PC. So first time alone we should be able to see a broadcast packet, and again if I'm pinging for the second time from this PC to the next PC, it will go directly from this particular PC, it will go to the switch and it will go directly to this PC. Okay, so now let us go and see how it is working. So first I want to ping from 10.0.0.3 to 10.0.0.4. So there is a ICMP packet and there is an R packet being simulated. Okay, so the PC, the switch has received the packet. It will be doing a broadcast to all the remaining nodes. Okay, so the particular PC alone will be replying the MAC address. So here you can see the R packet that is being traversing. Then the MAC has received. After receiving the MAC address, now it will be sending the ping packet. So now only your ICMP packet is coming. So now you can see it has, the switch has not forwarded to all the other nodes. It has sent directly only to this PC because it has learned. So now you can see there is a reply coming from this packet. It will go directly only to this PC. It will not be a broadcast. If, for example, if this was the hub scenario, every time a packet is coming, it will be forwarded to all the other PCs. So that is a basic difference between your hub and a switch. Okay, so this is STP packet. This is not. By default, there will be a spanning tree protocol that is enabled. So we are not concerned. Okay, so let me put it into simulation mode. You are able to understand, this is how this is the basic difference between your hub and your switch. Okay, so still I think since I shifted from real time to simulation, it is again happening. Okay, so once the other PC has replied, you get a successful message. So this is how you can understand the difference between a hub and a switch. Okay, students. Okay, again, let me show you the same scenario. So now let us go and see whether the switch has learned the MAC address. So here you can see it has learned the various MAC addresses and the various devices that are connected to the various ports. So this is how your switch learns the um, various MAC addresses of the different PCs that are connected. Okay, so now let us go and see the next device. So I'm just moving my window to the right hand side so that I can just go and simulate the next type of device. So the next type of simulation that I'm going to show you now is a repeater. A repeater is again a layer 1 device where we use a repeater as example. For example, I have a building. So for example, let us take, I'm sitting in tech park. I have many systems connected in the tech park, and there is a biotech building, right? So there also I'm having few systems, and if I want to uh, imagine that I'm sending a data from this tech park to biotech park. This is a very small distance, but for example, if you take a area where two buildings are nearby, and if I'm sending some data, the we know the sometimes your signal strength might degrade. Okay, so signal strength might degrade means we know that the data will be in real time, the data will be converted into zeros and ones, and we know the signal. Zeros means you can for example, a zero means will be represented by a no bit, one means will be represented by a positive. You know that, right, how your signals will be represented. So as and when I am transmitting some data, the signal strength might be reduced. So in order to amplify the signal, we'll be using a basic device. It's a layer 1 device, which is nothing but your physical device called as a repeater. So a repeater, so let me click on the, in the hubs itself, you can see there is a device called repeater. Okay, so you can just connect a repeater Here. So if you click on the repeater, here you can see a repeater is a two-port device. Okay, you can just have two ports, and here you can see there is a power button called green button, so you can just turn it off or on. Okay, so here you can use a repeater if you want to enable, or if you want to increase the strength of the signal that is being sent from one device to the other device. Okay, so I have a repeater over here. So next is setup I am showing you. For time being, let me put it a switch. So let me take one switch. Okay, and under the switch, let me put some PCs. Okay, PC1, PC2, PC3. I'm just using the connection. Okay, I'm just using a straight through cable. I'm just connecting the next device. Okay, I'm just connecting to the Ethernet port. Now I need to connect it from the switch to a repeater. Okay, Ethernet 0. Now again I need to connect this switch again to the repeater. Okay, a repeater is called as a two-port device. So here you can see there are only two ports. You don't need to assign, like similar to a hub, there is no configuration. You don't need to give any IP address. Okay, just you need to connect the devices. So here you can see this, since we have connected this particular port still in amber color, so which means the switch is not yet ready. So meanwhile we will try to ping between the devices. We know we are able to communicate between the devices in this particular switch, right? So for example, I'm just pinging a data from this to this. Yes, my communication is successful. So likewise, from this to this, whether I'll be able to communicate, it is saying an error call PC8 has no functional ports. So what is the reason? The reason is I have just added the PCs, but I have not given the IP addresses, right? I just put the PCs. So I have to go and assign an IP address. So if you have not assigned IP address, you get an error call as no functional ports. So let me go and give this address like 10.0.0.11. Okay. So let me go and give it as 10.0.0.12. Okay. So you have to go and give 10.0.0.13. Okay. So I'm using, what is the address? So I've used 11, 12. Okay, so here it will tell you fast Ethernet, it is 13. Okay, so whether we are able to ping between these devices, you can go and check. So here there is a successfully I'm able to communicate among these devices. I am also able to communicate among these devices. Now we will see whether we'll be able to communicate between, because all this belong to a single network, all the addresses are the same. So you'll be able to communicate between these devices, but the work of a repeater will be, it will be enhancing the signal strength. In case if the signal strength is weak, the repeater's task will be to enhance the signal strength. Okay, so you are able to communicate from this particular PC to the other PC. Okay, so that is a basic working of your repeater. A repeater is a layer 1 device which is called as a physical device where you will be able to connect. So if you are able to see the port here, means which means that you can connect one cable over here and the other cable over here. Okay, so this is how your repeater will work. Okay, so now let us go and see the configuration of the next type of device. So now we'll go and see how to configure a router. I hope I'm not very fast. I'm able to deliver the content. You are able to follow what I'm teaching. If you're having any doubts, you can get back to me, or you can contact your faculties, because all the faculties are familiar. Okay, so you can get the help. In the lab also we'll be able to troubleshoot, or we'll be able to help you out. Okay, So next, let us see how we are going to configure a router. I think all of you are able to follow, right? One second, let me just mute myself. So meanwhile, if anybody is having any doubts, you can post it in the chat box. One second, I think I have to again stop the presentation and present it. You are able to see my screen, right? Okay, if you're having any questions, you can post it in the comment, or let me go to the next type of configuration. Okay, so now let us go and see how to configure a router. Okay, so I'm just deleting this repeater, and let us see how to. I'm just deleting the repeater. Okay, press escape. This cross button will go. Now I have a few systems connected to one switch, and I'm having a few more systems connected to the other switch. Now let us see how to introduce a router. So a router, if you see, so if you click on the network devices, you have the round button. So here you can see what type of device. This is a router. Here it is being displayed. Next it is a switch. It is a hub. Likewise, you can see the various devices. So if you click on the router, a router is nothing but it will be a uh, it will be a round device, okay, with the cross. Now you need to connect the switch to a router. So the basic connectivity will be, the PCs will be connected to a hub will be connected to a switch, then a switch will be connected to the router. So this is how you will be connecting basically. But I have connected to the switch because I showed you the switch configuration. But you can connect the PCs to a hub, and then the hub can be connected to a switch, and then you can connect it. So in the theoretical class, they will teach you the topologies. Uh, Topologies is nothing but how do you physically connect the devices. So you have various topologies like bus, star, ring, mesh, tree topology, etc. So since you have connected the PCs to a hub or a switch, you can say this as a star topology. Star topology means that you have a central hub, and all the communication will be happening via the central hub. Okay, so you will be learning all that in your theoretical classes. Now for time being, I'm just showing you how to connect these devices and how to configure a router. Okay, so as I already told you, in your lab exercises, we'll be learning you the commands. You will be learning the commands, how to configure a switch, how to here you can see, right, there is a switch. You can go and give a particular name, like what I can say, lab 1. Likewise, you can go and change the name, you can go and set the password. So initially, if by default you will have this menu, so you can give enable this, it will take you to the next prompt. So you'll be learning all that in the lab exercises, how to give the password, how many users to allow, all that you can do in the commands. Okay, so you learn all that. So now let us go and see how I'm going to connect a router. So I'm just using a straight through cable and just connecting it to the gigabit ethernet of the router. So likewise, I'm taking another cable and I'm connecting from this switch to the router. So what about a router? A router is a layer 3 device, or which means it is a network layer device, and it is basically used to connect to different networks. Okay, so that is how your router will work. Router will be also having a routing table. Okay, so I have just connected a router. So let me show you how a router will look like. So this is how your router physically will look like. So why we are going for this Cisco software, as I already told you in the initial class itself. So these devices are costly, and if you are doing some configurations, and sometimes it will be difficult for you to do the configurations, and even if you do a simple mistake, it will take you need to spend a lot of time to troubleshoot. So that is the main reason. First, you need to practice it thoroughly in your Cisco packet tracer. You should be able to be clear with all the concepts, where to configure, how to do, etc. So once you are familiar with the packet tracer, you can go and work in the real time, because in real time, all the major companies, they'll be using all these devices, and there is a lot of scope. There are a lot of job opportunities for networking, and it is an always you can see security jobs, networking related jobs in all the companies. Okay, so let me go into the router. As I showed you the router. So here, if you click on the config, here you can see it is having 3 gigabit ports, and I have connected to this. I have enabled the port label, so that is why I am able to see to which port I am connected. Okay, so by default this will be disabled. If you go to preferences, uh, always show port label will be disabled by default, because you will not know, you will be searching each time. So that is the main reason I have given the option called show port label. Here you can see that I have connected to a gigabit port. So in this scenario, I have all the IP addresses for this, and I also have all the IP addresses assigned to these pieces. Now, what is the next thing that we have to do in case if you are going for a router? So router, there are two interfaces. Here I'm having gigabit Ethernet, and here I'm having another type of 0 bar 1. So one second, let me push this side. See, okay. So generally, whenever the PCs are communicating via a router, all these PCs. So I'm introducing the next concept for you. So here, if you click the PC, here you can see you have something called as the IP address, subnet mask, default gateway, DNS server. So default gateway by default it is 0 in all the PCs. But whenever you are connecting a router, you need to have a default gateway address. So the default gateway address of all these devices will be this IP address of this particular router interface. Okay. So similarly, the default gateway for all these systems will be this particular router interface. Default gateway is nothing but router will be basically used whenever we want to connect to two different networks. So for example, this you can consider as one network, and the other interface you can consider it as a one network. So I will show you like logically, because I've used all 10 addresses, you'll get confused. So I will show you with the different address. Like for this particular zone, I will give one IP address. For this particular zone, I will give another IP address, and I will show you. And all the data that is generated by this zone has to go out via this particular exit interface, right? So that is the main reason for all these species. Whoever, for example, if this PC is trying to send some data to this PC, for example, I'm telling for this PC is going to send some data to this PC. The data has to come to the switch, and then it has to come to the router, and then it has to go to the next switch to the other router, right? So for this PC, the exit point will be this. So that is the main reason we have to go and give the gateway address of this particular interface to all the PCs. I think you are able to follow me. So likewise, for these devices, I need to point to this particular gateway device. Only then my data will be passing out of the network. Okay, so you just need to understand that a router will be used in case if you want to connect two different networks, and all the PCs, when you're connecting in via a router, it needs to have a gateway address. So since I'm using a 10 dot network, so I have used up to 6, right? So let me go to the router, and what is this address? 10.0.0.0. So you have to go to 10.0.0. not 10 dot, this is gigabit, right? So gigabit 000, go into that particular interface, and I'm going to give an address called 10.0.0.10. Okay, so always you have to, so if you give the IP address, by default it will prompt you with the subnet mask. And the major thing that you have to do is, so you can see that there's a port status. The port status should be turned on for a router. Only if you turn it on, you can see that the line protocol on the interface has changed to up. So that is where you can see this router port will become red in color, green in color, otherwise it will be red. So here you can see, if I'm clicking, what is this port number? 0 bar 0 bar 1. So if you click on 0 bar 0 bar 1, so I will tell you what address I'm going to use the other side. So what is this address I have configured? 10.0 bar 0 bar 0. I have configured 10.0.0.10. Okay, so coming to this side, so let me go and use another type of address. I'm using 192 dot addressing you will learn in your class, but for time being, just bear with me. I'm just using another type of address. So IP addressing, there are 5 classes of IP address called class A, class B, class C, class D, and class E addresses. A class A address will start from 1 to 126. You will learn all that. So for that, basically, I'm using a class C address over here. Okay, 255.255.255.0. So this is a class C address. I'm using it for the other side. Okay, I've used 10.1. You have to give you have to give correctly, because always you can find that instead of 192, sometimes you might type just 19, 198.1, 192.168.10.2. Okay. Okay, so I'm using this, I've used 10.1. Okay, for next PC I've used 10.2. So next PC I can use 10.3, 192.168.10.3. Okay, so by default you have to use, it's a class C address, so by default it will pop up. Okay, 255.255.255.0, it will pop up by default. And I have to go and give this gateway address over here. So this address is 0 bar 0 bar 1. So you have to go into the correct interface and give, otherwise it will not work, because you will type in some other place 192. Okay. So always before doing the configuration, you have to draw this PC in a paper, give the IP addresses, what IP addresses you are going to give, everything you have to have the diagram, and only then you have to go and install it. Otherwise, it will be difficult for you to do the configuration. Okay, I have just given the address. So here you can it is still amber in color. So let me check whether I'm able to communicate with these PCs, and then we'll go that side. Okay. So I'm just communicating from this PC to this PC. I'm able to communicate. Likewise, I'll be able to communicate from this side also. So this part is working fine. This part is working fine. Now we need to check whether you are able to communicate between the two different networks. Okay. So whether you will be able to ping or not. So I want to send some data from this side to the other side. It is failed. So similarly, the other side also, if I want to send some data from one side to other side, here you can see that there is a failure, which means we have done some mistake. So what is a mistake? As I already told you, you have to go and give the default gateway. So I have not given the default gateway 10.0.0.10. So only if you go and give the default gateway address. So for time being, as we are running short of time, I will just show you for this PC alone. For this PC, I have given 10.10. So this is the correct address, right? So I've given 10.0 to 0.10. Okay, so likewise this side is 10.10. So for this PC, let me go and give the default gateway address 192.168.10.10. Correct only, right? 192.168.10.10. Okay, so now I have given the gateway address. So let me see whether I'm able to ping from this side to this side. So first time alone it will fail. Why? Because it will learn. So next time it will be successful message. Okay, so here now you can see that I am able to communicate. So let me try from the other side. From the other side also, you will be able to ping from this system to the other system. So you can we are in the real time mode. Likewise, we can go into the simulation mode also, and you can check it. Okay, so I told you how to work in the real time mode and how to work in the simulation mode. You can just try it by yourself. So here in this particular scenario, I have used only one router. So you can make complex scenarios by adding two routers, four routers. You can change the background. So I think I leave it to you to explore the tool. You can change the back, you can give colors, you can add templates, or which means the background. So you can play around with the Cisco packet tracer tool. So I think I have covered the basics of hub, switch, router, PC, ARP, and ICMP protocol, etc. I think students, you are able to follow with my teaching, and if you have any doubts, you can get back to me. Um, I hope you understand Cisco packet tracer, and I think you really like the class, and you are really eager to explore the Cisco packet tracer tool. So this is a very excellent tool where you can play around with the tool. Like you can give the you can change different devices, addresses, components, and you can just play around with the tool. Okay, students. Wait 1 second. Actually, we are posting the feedback link in the comment window, so you can just give the feedback about this session, and one, and you can practice. So I think there is no issue with you to download and work with the tool. No problem, no issues. In the computer communication subject, the faculty will teach you from the basics again. You will learn how to install the software, and you will have a hands-on session on the Cisco packet tracer. So I hope you enjoy networking, and you also enjoy working with the Cisco packet tracer. Okay, so I'm just muting myself for 2 minutes. I'll get back to you. Students, we have given the feedback link. So kindly fill the feedback link. And if you're having any doubts or any queries, you can get back to me. My mail ID is savitd, S-A-V. I will just chat. I will just put it in the chat window. Savitd at the rate of srmist.edu.in. Okay. My cabin number is 203A in Tech Park. No issues. You will be learning all this in your computer communication lab. So don't worry. You will be able to do it in the lab. Okay. So we have given the feedback link. So kindly fill the feedback link. So there is a question by Hetam. So how do I do static routing for mesh topology using four routers? No worries, Hetam. So this is a very fundamental or basic class. You will be doing it in your lab. Okay. So static routing, you might be knowing, but there are other students, they will not know anything, right? So no worries, you can do it. Okay. You have the commands. You'll be doing it in the lab. So don't worry. Okay. So I think, hope you had a wonderful session, and thank you, students, for joining us. All of you submit the feedback form without fail, and thank you for joining us. Thank you from the Department of NWC, and I also thank Dr. Annapurni ma'am for giving me this opportunity to explain about Cisco Packet Tracer, and I'm really humbled. Thank you all for joining. I also thank all the teachers who have joined, and also all the students who have taken time to attend this session. Thank you all, and I also thank my um, coordinator, Dr. Jairaj sir for assisting me for helping this session. I also thank Dr. Godwin for helping me to do this presentation. Thank you, all of you. Thank you for joining. Have a nice day. And I hope like tomorrow you have the exam. All of you go and study. Okay. Thank you for joining. Thank you all.